Okay, brother.
Tapi if you studied, if you done, unless you hantar benda yang semua salah lah. If you have done something, okay, okay, maknanya you have done your part lah. Okay, kalau segi masa tu nanti saya tengok macam mana. Is it okay? If it is a fair complaint, okay, I'll try to look into it. Okay, macam mana nak support or to help you all lah. Okay, tapi make sure you have done your part lah. You have done your assignment. You have attended the class. Tapi kalau semua tu tak ada, saya tak boleh bantu lah. Okay. Okay, untuk hari ni, okay, let's move to the lecture. Okay, I will share with you apa ni PowerPoint. Sekejap Okay, kita ada topik yang berkaitan dengan control chart. Kita belum habis lagi ya. Saya nak terangkan nanti S chart, attribute control chart dan sebagainya. So, sebelum itu, let us okay, where is my sharing button? Tak nampak pula ni. Okay, I would like to share with you. This is from my friend in Sirem. So, what we know now, Industry 4.0. I think all of you, most of you have heard about it. Industry 4.0. And in parallel to that, we have Quality 4.0. Okay, what is Industry 4.0? Anyone? Any idea what is Industry 4.0? This is hot topic now in industry, even in academics, in the media, talking about Industry 4.0. Apa itu Industry 4.0?
Integration internet.
Okay, maknanya internet digunakan di dalam manufacturing. So, or sometimes we call it smart manufacturing. Okay, pernah dengar kan smart manufacturing? Smart manufacturing. Okay. So apa itu smart manufacturing? What is smart manufacturing?
Digitalized manufacturing.
Okay, very good. Okay, we use digital technology in manufacturing. Okay, so all digital technology are used. Okay, so we have Industry 4.0. Okay, before that we have Industry 1.0, Industry 2.0, Industry 3.0, Industry 4.0 now. In fact, people are talking now 5.0 and so on. This is just a label, classification. So Industry 1.0 is basically using mechanization, steam power, okay, to what do you call it, to replace human punya energy, human power with steam engine kan. Lepas tu ada Industry 2.0. Okay, penggunaan penggunaan automation. Okay, 3.0 more using computer, electronics dan sebagainya. 4.0 using internet, okay, digital technology. So in parallel to that, we have quality. One of the function di dalam industri, dalam manufacturing. So quality 4.0 bermakna we use digital technology, internet technology, artificial intelligence dalam quality. Okay, so all what you learn now will be goes to computer, automation, smart system, yang penggunaan smart system untuk quality. Okay, control chart is done automatically in the devices. Okay, it will be done using intelligence to analyze quality, but the concept is the same. Okay, so the human function, manual method for decision making can be taken over by computer, and internet will be used for communication. Devices yang mengukur quality will be linked to equipment. Okay, so in fact the devices contohnya macam IoT, okay, Internet of Things. Okay, Internet of Things ni macam extension of sensor lah, sensor system. Quality pun kita ada sensor system, sensoring system. Sensor is used to collect data, send the data to the manufacturing system. Okay, this data will be analyzed. The data in our case is quality data lah, measured data. This measured data has to be analyzed. Okay, will be used for decision making. Macam kita buat control chart is for decision making. Okay, decision making related to process. Either the process is okay, or the process has to be stopped, or the process has to be adjusted, okay, for decision making. Okay, in the past, human being has to decide. Now, computer is used to make decision making, okay, on behalf of human. Tentu kita ada artificial, okay, intelligence. Okay, artificial intelligence. So there are many technologies related to this. Okay, so I just would like to expose, okay, at this stage for you. Okay, what are the things that we need to be aware of this development. Okay. Okay, let me directly jump to this one first. Okay. Okay. So quality 4.0. Okay. Quality 4.0. Okay. These are the tools for quality 4.0. Artificial intelligence, big data, blockchain, deep learning, enabling technologies, machine learning, data science. So sebenarnya when you learn quality, okay, when you learn about Six Sigma, you need to relate to data science or data analytics, because we are dealing with data. Okay, quality basically dealing with data. Okay, so we need to adjust ourselves so that we also have understanding on data science, data analytics. Okay, I'm sure that you are aware there is high demand for data science, data scientists now, high demand, okay, in employment. Tempat kerja dia nak cari siapa yang boleh buat data analytics. Are you aware of this or not? The need of data science, data analytics. They have what do you call it? They are in high demand. Okay, those who are able to interpret data. Okay, those who are able to analyze data and to make decision based on data. Okay, so quality, what we have now, we study Pareto diagram, we study control chart. Okay, we study all this data to find the statistical values in the data. Basically, it's related to data science. Okay, related to data science. So, in the language of quality, we call this quality 4.0 lah. Okay, are you following me or not? Hello.
Yes, sir.
Okay, so
Yes, sir.
so all this technology macam artificial intelligence, big data, blockchain, deep learning, these are coming from computer science. Okay, machine learning, but it can be applied in quality system. Okay, So it can be applied in quality system, and if we have the knowledge in this technology, okay, you will be in good demand. Okay, we also discuss about Six Sigma. Six Sigma. Okay, now people are trying to understand how Six Sigma can fit in into Quality 4.0. How can we match Six Sigma and Quality 4.0? Any idea? Six Sigma is related to data, right? We need data for Six Sigma. Okay, we have define phase, we have measure phase, okay, we have analyze phase, improvement phase, and control phase. All those are related to data. How can these Quality 4.0 tools can be used in Six Sigma?
From the big data,
Okay, from the big data,
we define macam mana? AI define, then measure, analyze the whole data, and improve in the apa? In the process lah.
improve in the process. Okay, very good. You have some idea there. Okay, ada orang lain tak nak bagi idea lagi? How we can use all this technology in DMAIC? Okay, in define. Okay, define the problem. Okay, in define the problem. In measure. Okay, in analyze. Okay, improve.
Maybe like creating a simulation.
Okay, so simulation also one of the tool in Industry 4. Create simulation. Simulation like what? Any idea? Process simulation?
Yes. Dia
Okay,
macam simulation untuk banyak situation.
okay, you can test different parameter, different setting, put in simulation before you actually run the process, boleh? Okay, we can do process simulation. For example, you want to cut a surface, kan? Guna lathe machine. You can change different parameters, okay, different setting, okay, test it in simulation and get the result, which one give you a better quality, better dimension, better surface, for example. Yes, this tool can be used in process design, but in quality, where it's going to be used? For quality, we are talking about, identifying the problem, measure the problem, analyze the problem, implement, improve and control. So in Quality 4.0, we have the IoT, okay, Internet of Things, okay, which is basically industrial sensors lah. Okay, this is like industrial sensors. Okay, in the industry, you want to measure quality, you need to use sensors. Okay, so we need to collect data. You need, for example, use string gauge, for example, to collect some converting some data into electrical signals. Okay, you use vision system for inspection. Okay, secara traditional, people use human being using their eyes to check whether good quality or bad quality. But now, vision system is used, okay, to detect whether the product is good or no good. So these are some of the automation in quality, in quality. So where you get data. So in our course here, we are talking about control chart, we are talking about Pareto and so on. So this is assuming data already collected, okay, but we also need to understand where this data come in. For example, in your test, you are given data, quality data, and convert this data into control chart. But before the data can go to that table, this data has to be collected. Okay, quality engineer also need to understand how this data is coming. So it must coming from measuring instrument. Okay, what are measuring instrument? It can be a simple devices. In the past, people are using, for example, micrometer, vernier caliper. These are basic lah. And also can even use some sensor. Okay, for example, proximity sensor, can use digital devices, okay, to detect the distance, to detect the gap, okay, to measure a deviation. Okay, so those are sensing part where you collect data, and this data will be transferred into data logger and then goes to computer to analyze. So what we have seen so far is assuming data already available, and then you analyze those data. But before data coming, is also concerned with the hardware of the quality, the hardware part. So we look at bigger perspective now, quality related to big data. So when we have big data, we need to know what are the technology in big data. Okay, how do we represent data so that people can understand? If we just look data in terms of table, we cannot get the information. Okay, we cannot get the information because why? Because those are just compilation of numbers. Okay, so data has to be converted into graphical, for example. Okay, graphical display can be in terms of control chart, can be in terms of histogram, can be in terms of other charts, maybe spider chart, or maybe in terms of fishbone diagram, can be in box plots, and so on. Okay, so people also talking about blockchain. Okay, blockchain. This is computer science, but we need to be aware it's also related to quality, especially in terms of we want to see traceability, of information, authenticity of the information. Information is not being corrupted. Blockchain, so you can trace the characteristic of what you're being produced is not being tempered, okay, along the way of the transition of the process from one station to another station to another factory and so on. Okay, deep learning also related to artificial intelligence, where the decision making, okay, can be more accurate. Okay, so these are some of the enabling technologies lah. This is talking, I think about this photo here macam drone ni, drone. Tapi basically this industry 4.0 are very much related to quality. That's what I want to try to explain here. Okay, machine learning, data science. Okay, data science and big data, they are related lah. Okay, so if we go back to the quality. Okay, quality 4 is leveraging the technology with people to improve the quality of organization. Okay, its products, service, and the outcome it creates. Okay, so basically we want to leverage the technology. Okay, leveraging of technology. Okay, what are technology? Those technology of artificial intelligence, okay, internet technology, data analytic technology, to improve the quality organization, okay, products, services, and so on. Okay, those are just the definition of it. Okay. So the term 4.0 referring to the future of quality, okay, in the context of industry 4.0. Who said this? This is coming from Quality Association, American Society of Quality. Okay, quality professional can play a vital role in leading the organization to apply proven quality discipline to new digital and disruptive technology. Okay, so we have to be aware that now there are disruptive technology. Okay, so who are quality professional? These are industrial engineers. If you study industrial engineering, one of your profession will be maybe involving in quality. Okay, so you need to lead. Okay, how to implement this quality 4.0. Okay, so to a new digital environment. Okay, and disruptive technology. Okay, what is disruptive technology? Anyone has any idea what is disruptive technology? Hello? Disruptive technology. Any idea? Can be maybe in manufacturing, they have disruptive technology. The technology will make other technology obsolete. Okay, I give you example. You heard about electrical vehicle, right? Using electric as power for automotive.
Yes.
It's going to replace the petrol, right?
Yes.
Is it disruptive technology?
Yes.
Okay, so maybe in next 20 years, we can see less petrol station. Petrol station might be obsolete. Okay, people will be using electric vehicle, okay, which is run by battery. Okay, so the battery will be charging. So battery technology now is one of the hot topic. People research into battery technology because the future car will run on battery. Okay, the battery will be powered, okay, by solar and also maybe electrical charging. Instead of go to petrol station, you will go to the charging station. Okay, these are disruptive technology that will make existing technology become obsolete. Okay, this is like in the past, people are using typewriter to produce document. When the computer come in, the manual typewriter obsolete. Okay, so we can see that this is coming. Okay, so what will happen is it will wipe out, okay, the workshop. Okay, there will be no workshop for repair engine. Okay, because you are running the car using motors. Okay, what will happen to those workshop when electrical vehicle is coming more dominant in the market? What will happen? I'm asking you. Anyone?
If the workshop follow the changing in technology, so it can still be alive.
Okay, so meaning that they also have to learn, right?
Yes.
This is what people say: learn and unlearn. You know, learn, relearn, and unlearn. So because the engine is motor, okay. So those who are in the business of producing petrol engine, which are the traditional technology, okay, they have to adjust themselves, okay, because this the new technology is running cars, vehicles using motors and batteries. Okay, why there is a need to change to motor instead of petrol? Why there is a need there? Is it because of
Petrol is a renewable source.
petrol is not renewable cost, it's not renewable, and it's also damaging to
Environment.
environment. We are now our environment is really at serious situation. Okay, even if the environment increase by 1.0 degree, okay, if increased by 0.0 degree, a lot of imbalance will happen, okay, to the global. Okay, there will be kemarau, there will be drought, and there will be rising water level. Okay, in fact, some cities is predicted will disappear when the sea level increase. Okay, even by 1.0. So now it is a very serious effort being done now to reduce the global warming. Okay, global warming. So one of the aspects that has been identified is transportation, burning a lot of fuels, a lot of carbon go to the air, create global warming. So to address this need, this challenge, okay, engineers, scientists have come up with, okay, replace this carbon, burning instead of burning the carbon, okay, which is emitting carbon dioxide to the air and increasing the temperature of the global Earth, okay. So we replace the energy using electrical energy, okay, to take care of environment so that, okay, the mankind, the human living on the earth, okay, still can survive, okay. Increasing temperature will create a lot of problem. Plantation will not grow properly, will not be enough food. Okay, this is drastically, okay, the rate of change is very drastic, okay. So that's why there is a push to go to electric vehicle. Okay, so this is what we call disruptive technology. Okay, I give you another example of disruptive technology. In automotive, there are so many components, right? So many components to assemble and to make it a car. Okay, you have to assemble hundreds of components, small components where robot is being used. In the past, robot is used to replace human. Okay, human workers replaced by robot because of to get it faster, okay, get it more accurate and so on. But now robot is being replaced by what? In automotive industry, for example. Who is replacing robot? Robot pun hilang kerja juga hari ni. Who is replacing robot?
Smart robot.
Smart robot, eh? Not exactly. Okay, in automotive, there are so many assemblies, right? Assemblies of components using screw, using nut, and so on. Okay, if you follow the development of what we call this, okay, Tesla is pioneer in this disruptive technology. Have you heard about Tesla? What is Tesla?
EV company.
EV company. Okay, so they have implemented this what they call GigaPress. You heard about GigaPress? Automotive industry has a lot of components, so they need a lot of robot in the past to assemble the component. Then instead of using human, robot have taken over from human, okay, to combine small pieces to make it, assemble component. Before now, the robot losing the job to the GigaPress. Okay, what is GigaPress? Anyone? This is disruptive technology.
Die casting machine.
Yes, very good. Okay, a very big size of die casting machine. So you do die cast, okay? So you don't need to assemble, right? When you have a big piece coming from just one shoot of the GigaPress, which is very big, mold that you put there, coming out, from the press. So one piece rather than many pieces where you need to assemble. So because assembly is not needed in that case, okay, robot losing the job. Still need robot, but instead of hundreds of robot, maybe you need just a few robots only. Okay, so this is what I call disruptive, disruptive. So it change, making others become obsolete. So we need to be aware that what are coming and what is changing us, the technology, in the technology. Okay, so okay, if we make comparison between industry 4.0 and quality 4.0, okay. So if we know that in this some historical we need to understand the history so that we are able to appreciate what happening. Okay, late 90s, late 80th century. So where steam and water power was used. This is during the period of industry 4.0. Okay, 1890, okay. So where the machine are powered by water and steam, okay. Industry 4.0. So in terms of quality, we call it quality 1.0. Okay. So quality is assured through measurement and inspection. Okay. Basically, still a manual approach lah. Production volume is more important than quality during this period. Okay. So during industry 2.0, which is until 1940s, 1940s. So 1940s, which is less than 100 years ago. So people are using electrical power, okay, automation, mass production. This is where the Ford Motors pioneer in assembly line production for cars. Okay, this is we call it industry 2.0. Looking from quality perspective, we call it quality 2.0. Okay, so where we are using standard component, okay, to produce in high volume production, similar products using standard component. The target was improving the productivity, okay, improving productivity, reduce the cost. So this is where automation is coming. So, okay, those are finished there. Okay, from 1940s until 1995, computers start to appear. Okay, computers are used, okay, for information processing, to control, okay, to control the machineries, the robotics, okay. Industry 3.0, in quality, we call it quality 3.0, okay. So whereas, again, even the standardization in quality system, for example, ISO 9000 becoming more common, okay. Continuous improvement, okay. So in fact, computer is being used also to assist in quality during this period, okay. So after 3.0, go to 4.0, where we are now, okay, 1995 until currently, okay. Integrated cyber physical interface to automate the working environment. Cyber mean internet, okay. So you have internet system, you have automation of machine run by computers linked to internet, okay. In fact, the computer in the past also connected to network, but they are limited to within a factory. But now, computers are connected to internet. You can monitor the running of the processes from remote area. You can see what's happening in the factory by looking into internet, devices connected to internet. It could be computer, it could be handphone, okay. You get messages when there is something wrong with the machine, sent to your smartphone. Okay, this is the area, the situation technology that we have now. People are controlling the process using smartphone, okay, receiving information about performance of machine through devices, mobile devices, not computer which is fixed in the office, but mobile devices. It can be iPad, it could be portable computer, it could be even smartphone now can do some of the function of mini computer. Okay. So the issue, the invention of artificial intelligence, machine learning. Okay. So when we go to quality, this is what we need to be aware now. Okay, you need to be aware. Instead of learning control charting, X bar, we need to be aware of quality 4.0. Okay. Digitalization to optimize signal feedback for process adjustment. Okay. Quality shift from process operator to process designer, machine learning, and so on. Okay. Let me stop there. I would like to share with you how AI can be used, okay, in quality. Okay, how AI can be used quality, because this is important understanding. We need to understand the basic traditional way of measuring data for quality, putting on control chart, putting on what do you call it, runs rule, and so on. But actually, our target is beyond that. We need to automate the function of quality. Okay, let me share quickly with you this Okay, do you see my slide now?
Ya sudah.
What do you see?
Pattern
Pattern recognition.
recognition.
Okay, so pattern recognition is one of the technology for artificial intelligence. Okay, we use artificial intelligence for pattern recognition, for quality monitoring and diagnosis. Okay, so let me explain to you about pattern recognition before we go to how that pattern in control chart. We are living in a world of patterns. Okay, because I presented this in Indonesia last year, it was popular batik there. So batik is a pattern. Also, if you go to bank, you see that your thumbprint. Okay, you want to get the money from your account, you have to put your thumbprint. Your thumbprint is also pattern. What technology is being used in thumbprint recognition? How do you know that this is you, not somebody else? Can somebody else go and show their thumbprint? Can or not?
No.
To get your money, cannot, right? So this is also pattern. Okay, technology of pattern recognition. You can use artificial intelligence and you can use also statistical techniques to recognize this. Okay, people also using face for face recognition. Okay, face recognition for payment. Okay, now you make it online banking. Okay, you go to a shop. Okay, you just scan. This also pattern. What pattern is this? Now dalam MySejahtera also you need to scan. You see this pattern. What do you call this pattern?
QR.
QR. Okay, QR. By our naked eyes, we don't know what is it. I just scan out. We know that this is location that where you are in. Okay, so pattern recognition is very important. Okay, you go to hospital, it's also pattern. Doctor is looking at your heart rate and so on. Okay, monitoring health. Currency exchange, the stocks exchange, also showing patterns. Okay, people studying the pattern of changes. Okay, vibration pattern. If you study mechanical, you may be interested to see the pattern of vibration for the bearing. Okay, what information we can get if we get the vibration from bearing? What information we can get? Let's say this is bearing. You can monitor using sensors. You can monitor this vibration of bearing, put a sensor there, and the vibration from that parts of the devices can be collected, convert into electrical signal, and display in the display monitor to show some of this. So you can interpret this, the behavior of the changes. Okay, when there is high peak, low peak, and also the cycle of changes. Okay, analyzing this pattern, okay, can give information to us when to change bearing. Okay, so again, it is pattern. Okay, it's a pattern. Okay, are you familiar with this design? What is this?
Cylinder.
A cylinder. It is like a technical drawing, right? It's a technical drawing showing cylinder. So it shows the cylindricity. Okay, this is a part of GD&T. Have you studied GD&T? Geometrical dimensioning and tolerancing.
Yes.
Okay, geometrical dimensioning and tolerancing. So one of the symbols, for example, cylindricity. We monitor the cylinder, not only the diameter, but the shape, the profile of this. Okay, so we can see that what is showing here is what we design is not the same as what we produce. This might be the real production. Yeah, this one is real production, which is varies. Okay, it follows certain variability. Okay, what follow variability? We have been talking about process variability. Okay, this variability demonstrate certain pattern. Okay, demonstrate certain pattern. Okay, so this is during 1980s. We can have this technology where computer is used to monitor or to measure. You can have these digital devices connected to computer. Okay, computerized. we call it computerized statistical process control. Okay? So we have seen this before. You cannot produce exactly the same. There will be variability. This is also, you have learned about it, random cost, assignable cost. Even in the test also, I asked you, right? The difference between this. Okay, I think we can skip this part. Okay, this is what we call random Nelson runs rule, where we try to interpret variability of measured data. Nelson's run rule is saying that if we can analyze the fluctuation or changes of the point within control limits. Okay, this is within control limit. Within plus minus 3. See, this is happening within. Okay, so if we just identify one point outside the control limit, this is called rule number 1. 1 point beyond zone A. This chart showing that you have A, B, C, and then C, B, A, meaning that 1 sigma, 2 sigma, 3 sigma on the top, and also 1 sigma, 2 sigma, 3 sigma at the bottom. So altogether, the control limit is divided into 6 zones. 6 zones. So the simplest rule is rule number 1. Anything beyond plus minus 3, the process is considered as unstable. But in actual situation where we want to achieve 6 sigma quality, we need to consider also what happened within control limit, not only outside control limit. So we have to study, okay, if this is plus 3 sigma, this is minus 3 sigma. Okay, not only looking at outside, but also we need to look at inside. Okay, inside of plus minus 3. So meaning that we have to study the pattern. This is a pattern inside. This is a pattern inside. This is a pattern inside. This is also pattern inside. Okay, this is also a pattern inside the control limits. This is also a pattern. Okay, this is also a pattern. This is also a pattern. Okay, so this pattern we call it Nelson runs rule to determine whether the process is it assignable cost or natural cause of variation. Okay. So there are other charting techniques. Okay. This is to make a control chart more sensitive. EWMA, QSUM, nothing to do with. What I'm saying is people in the past in statistics, they are looking into this, how to improve the sensitivity of control chart. But with technology of artificial intelligence, okay, people are looking into integrating, okay, AI, okay, in this case, using neural network, okay, plus the traditional statistics. Okay, so we want to pass the responsibility that human operator do it in the past. Now machine will take over in decision making related to quality. Okay, especially it is within control limit. You see this within control limit, within control limit, within control limit. So this is where the area of what we call it pattern recognition. Okay, area of pattern recognition. Okay, right. I think I skipped this part. Okay, so the runs rule has been used. Okay, identify that. Okay, so this machine learning also now being used for pattern recognition. Okay, pattern recognition. Maybe I would like to briefly introduce to you how that pattern recognition can be done. Okay, it is basically a study from human behavior. Okay, so in our brain, okay, human brain, there are a lot of connection. We call this, okay, the neuron. The neuron. This is inside human brain. Okay, in terms of biology. So this is our brain is actually firing some signal. Okay, connected. Okay, in the network of neurons. Okay, people in biology, they have studied how human think. So you go to this, okay, in our neuron, okay, biological neuron, and they convert this into, okay, mathematical representation. Okay, something is coming, okay, something is coming, convert into mathematical, okay, summation of the signal, and something will be firing out, okay, firing out. So this is what we call it artificial neural network, where they copy the technology of the brain, how the brain works, how human brain works. Okay, we see this, our brain. So the connection of nodes and networks. Okay, the round circle here, the ball here, the round shape is basically is a node connecting to another node. Okay, so which node will be fire, which node will be inactive, and so on. Okay, so artificial, that's why they call it artificial. Artificial neural networks. Okay, it is basically is rooted from biology of our brain. Okay, the function of our brain, because human being is very good in recognizing. Okay, human can recognize face easily. Okay, you look at the face of your friend, you know this is Ali. You look at another person, you know this is Ahmad. Okay, human has this strength of recognition. So scientists study how the mechanism of recognition is done in the brain, convert into mathematical representation. Okay, they call it artificial neural network. Of course, this network has to be trained, okay, in order to recognize. So there will be training, there will be cases of application. Training meaning you are trying to give the correct connection, okay, among the nodes. Okay, so giving correct training, okay, will let this network recognize. Okay, we recognize the correct classification of pattern. For example, if we give this leaf, okay, this is a leaf from a tree. We represent this in terms of binary here. We divide this shape into pixel, okay, like a pixel. I think you are familiar with pixel, right? When you take photo, you get pixel, right?
Yes.
Okay. So this pixel can be represented by 0 and 1. And if you have color, representation is more memory required. Okay, 0, 1, 0, 1, and so on. And this data will go to the nodes, okay, the nodes here. And the node will be adjust itself in terms of connection to recognize whether is it a good tree or bad tree. You know, this classification is at the output. Okay, so depending on the configuration or network here, they will decide which one is the right leaf. Okay, maybe you have different type of leaf. Some leaf are broken, some leaf are perfect, and so on. So basically, learning from human brain. Okay, so of course, in computer they represent this into a mathematical multiple regression. Okay, where you have y equal to w1 x1 plus w2 x2 w3 to represent the connection. Okay, w1 is actually a connection of node to node. Okay, and so on. The mathematics behind neural network. Neural network is represented by multiple regression. Okay? So more high level of representation there. Okay, so there is training and there's testing. Okay? So there will be clustering and so on. So okay, in fact, you can have more elaborate network, more elaboration of network in terms of specialized classifier, generalized classifier. So where the scientists are looking into how to make a good decision so that you can make correct interpretation of the patterns, okay, of the quality. It can be patterns of vibration, pattern of control chart, can be pattern of medical signal, and so on. Okay, so I think some idea for you where quality 4.0 can be implemented using artificial intelligence. Okay, using artificial intelligence for interpretation of control chart. Okay, that is the message that I would like to share with you. How artificial intelligence can be used, to interpret data or pattern that we have on control charting. Okay, so the pattern on control chart is not only 1 point or any point beyond plus minus 3 sigma. There is Run's rule to interpret that, but Run's rule have limitation. Run's rule cannot exactly identify the category of pattern. It cannot tell you that this is trend up, or this is a shifting, or this is a cyclic, because every type of pattern can be related to the diagnosis. Trend up in the control chart pattern showing that there is a worn out component in the machine. If we have a shift, sudden shift in the pattern, it shows that something is broken. Okay, maybe your cutting tools or component in the machinery is broken, sudden broken. If the pattern showing cyclic, cyclical pattern, okay, if it shows that there might be something is losing, the machine, something is losing in the component of the machinery, or maybe your cutting tools has loosened, okay, need to go and tighten the tooling. So we are using the pattern here for diagnosis of the equipment that used for producing machine. So I hope that you get some idea how this, automation, computer, artificial intelligence, and this is the where some people call it, advances using, artificial intelligence for quality 4.0. Okay, any question to that? Hello?
No, Doctor.
Okay. If no question, I think I will stop here. I will see you again next week. Next week is the final week before the semester break, right?
Yes, Doctor.
Okay. So I will continue with control charting, and also I brief you also related to group projects next week. Right. Thank you very much. If there is no question, that's all for today. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
Thank you, Doctor.
Okay.
Thank you, Doctor.
All right.